So this is to walk you through how to do the rest of this document so you're ready for tomorrow. What you should have is the average distance and the average time. So I'm just going to make up some numbers here, and I'm going to use easy numbers even though I know you have decimals and fractions and all of that. I'm going to use an average distance of 10 meters and an average time of 1.5 seconds. So I would have already initialed that part. Average fall time. Average fall time is you divide your average time by 2. So my average time was 1.5. So on the next page here, I'm going to take 1.5 and divide it by 2. 1.5 divided by 2 is 0.75 seconds. Okay. Now you'll find the vertex of the parabola. The equation for free fall is this equation here. D is the vertical distance traveled, G is the effective gravity, and T is the time in the air. The effective gravity is 9.8 meters per second squared, which is 980. Since we used meters in my average distance here, I'm going to use meters in this problem as well. Plug in gravity into free fall time you found in step 4. So this actually is step 4. To find the vertical distance your projectile traveled. So D equals 1/2 times 9.8 times 0.75 squared. Okay, and then I'm going to go ahead and punch that out. When you punch it out, oh, you're not going to be able to see that. Okay, so when you punch it out, you can see that screen now. 0.75 squared, you have to square that first, and then multiply it by 9.8 and multiply it by 1/2. And you get 2.7, I'm going to round it up, 2.76. Okay. So this is 2.76 is my D. You now have the maximum vertical distance your projectile traveled. So it is the y value of the vertex. Those numbers are the same. Okay. Now obviously you would be doing all of this with your own data, but you're following the same steps. Alright, to find the x value of the vertex, simply divide your average horizontal distance by 2. My average horizontal distance was from this step here, so my average horizontal distance was 10. So I'm going to take 10 divided by 2 to get 5. Using the vertex you calculated and a start point of 0, 0, we're going to use the vertex form to find a value for A. Okay. This is the vertex form that we studied way back in the first part of this chapter. You have found H and K. H is the x value of the vertex, so that was 5. And K was the vertical value, or vertical y value of the vertex, which is 2.76. So I have H and K, and then they tell me to use the start point of 0 and 0, so that's my x and y. So I'm going to plug in 0 for y, 0 for x, H is 5 because that's the x value of the vertex, and then my K was 2.76. And then I'm going to go ahead and simplify. So we have 0 times A. This would be negative 5 squared, or 25, plus 2.76. I'm going to go ahead and subtract 2.76 from both sides. So I get negative 2.76 equals 25A. And then I'm going to divide both sides by 25. And when I do that, I get negative 0.11. Okay. So I found my value for A. Then we're supposed to use that to write in a final equation for the flight of my projectile. So I'm going to write this form here, but I'm going to plug in my value for A, my H, and K, because that's specific to this problem. So my equation is going to be negative 0.11, which is my A value, times x minus 5 squared, plus 2.76. Okay. And then, yeah, I think we're done there. That's my equation. Then the next step here is we're supposed to measure from the floor to the top of a desk. And I did that already, but now I forgot what it was, so just give me a second here. I'm going to measure. Okay. So it's 0.78. Oops. Disc height is 0.78 meters. So my y value, we have to translate the whole thing. Now, this is what we're translating, this equation, and by translating, I mean we're going to have to bump this up a bit. The whole graph, or your whole project, is being shifted up on the table. So the thing that has to shift up, or the thing that shifts our equation up, is this k value. So we're going to change that k value by adding the desk value to it. So everything is going to be the same. So if we're going to add 0.78. Now this 0.78 meters is going to be the same for everybody. So for your numbers, even though all of your numbers are different, it is going to still be 0.78. So I'm going to take 2.76 and add 0.78, and I get 3.54. Okay. Now we're supposed to put this equation into my graphing calculator. So I'm going to go ahead and turn this on here. So we have negative 0.11 times x minus 5 squared plus 3.54. I'm going to use a normal window, so I'm going to go to Zoom Standard, see what happens. Okay, I'm going to have to zoom out a little bit, or change my window a little bit. Now what this is showing is right here, it's leaving the table, and then where it hits the x-axis again, that's mimicking the ground. So it's leaving the table and it's hitting the ground in that spot. That's the spot I want to find. To find it, we're going to use Second and Calc, which brings me to the Calculate menu, and I want to find my 0, or the x-intercept. It asks the question left bound, so I just scroll over somewhere to the left of that point, because that's the point I want. I hit enter. Then right bound, I'm just going to scroll a little bit to the right. I'm going to hit enter again. When it says guess, you just enter one more time, and your 0 is 10.67. Okay. Now, what this means is when you, like at this point you're done, and you're ready for your summative. So whatever number you get in this box here, when we measure out your target tomorrow, that's going to be how far we need to put your target. And then if you've done the work correctly, you've taken your data correctly, in those 3 shots that you have, you should be able to hit that distance. And that's it.